Speaking of rocket science, when the astronauts return to the moon in a year or two or travel to Mars in the years to come, one of the biggest challenges is landing a spacecraft safely.
So San Diego State University aerospace engineers are tackling that challenge by developing computerized landing technology that will be tested in space as part of NASA's Tech Flight program. Joining us now with more on this exciting opportunity, Chair of Aerospace Engineering at San Diego State, Professor Ping Lu. Thank you so much for joining us, Professor.
Thanks for having me.
Let's start off with NASA's Tech Flight program just in general. Tell us about that and how your department got involved.
Oh, yes. This is a program that NASA solicits the proposals from all the developers of space technologies. And, people sending all sorts of technology that have to do with the space flight. And probably they receive, close to maybe 100 proposals. And then their team of experts will review those, and based on the evaluation and merit, then they selected, I believe it was 9 projects all over the country, essentially, and San Diego State University was successfully been selected as one of those.
So let's look at some of these that you're up against. Johns Hopkins, Harvard, among other professional, Purdue, University of Louisville. Now, you guys are all competing, is that right, to try to figure out a good way, a safe way, an efficient way to land a spacecraft?
Our team is for landing,
okay,
and other teams may have different technology, like life in space and communication, material, all sorts of aspects of it. So what we are competing is the novelty, the innovation of the technology in a particular topic that you propose. So that's how we got in.
So your technology involves landing safely. Tell us more about that and about the proposal that you guys had to submit.
Yes, exactly. It turns out, landing on the planetary surface is incredibly challenging. NASA plans to send the astronauts back to the moon in the next few years, and believe it or not, at this point, only 3 countries have succeeded landing something on the moon. Of course, the USA has landed, the only country that landed astronauts on the moon. And going forward, let's say if we want to land humans on Mars, that's going to be a completely new technology that will be required. And up to a few years ago, the US was the only country that has landed robotic rovers on the Mars surface. However, if we want to land humans on Mars, the spacecraft would have to be 50 times heavier, and the whole flight operation will be completely different from what we used to see. That's why new technologies are very much critical for that to be successful.
So is that the key, is the weight difference? Because we just saw moments ago what SpaceX does, where they land on a drone ship, which is unbelievable. 1969 and into the 70s, we landed on the moon. Like you said, we've landed rovers. So how is what you guys are doing different than what's happened already?
Exactly, it's a very good question. There are 2 key aspects of it. Not only our technology is completely autonomous, meaning that we don't need any external input either from ground or anywhere. The space allows the spacecraft decide precisely what it needs to do at any moment of time in order to land this thing safely and accurately.
So it looks at the situation below.
Exactly.
And adjusts.
And not only, most importantly, our algorithm allows the spacecraft to land with the least amount of propellant that is going to be used. Just imagine, in the middle of landing, you run out of your fuel. This is not good. It's a safety critically, particularly for human space.
And that almost happened on Apollo 11, didn't it?
Almost, almost. And by the time the Apollo 11 spacecraft landed, they practically depleted all the propellant. If they need to fly just a little longer, they're going to be great trouble. So this is the type of situation we're trying to avoid.
Professor Liu, maybe wrap us up. Tell us what's next. How does this technology get tested, and what's next for your program?
Yes, we will be implementing this technology in a rocket. And this rocket, obviously, it's not going to go to the moon, but it will fly up, and then our technology will actually steer that rocket. Take over, steer the rocket, and we'll try to land this thing with the least amount of propellant. And so the test will tell us whether or not, on computer simulation is one thing, in real flight, will it do the job? If it does the job, we're hopeful that we could help NASA in that journey going back to the moon and eventually to the Mars.
And so everybody, in this program at SDSU, so you have a number of people who are contributing to this. I know that by doing that, by not spending too much propellant, you can save more room on board a rocket. Is that right? For
Exactly right. Okay. Exactly. It's either with the same propellant, you have a larger margin safety, or you're pretty certain, then you could leave out that space for much precious payload like life support, scientific instrument, who knows. Our test shows that you could potentially, in a large spacecraft, save the propellant up to like 3 metric tons. Just imagine how much good you can do with that 3 metric tons. You can actually practically carry another person.
Wow.
So incredible.
I want you to explain to us the algorithm and how we get into this, but I think that would take all day long for us to begin to understand it. It's amazing work you're doing over there, Professor. Thank you so much for the insight. Good luck, and we'll be following along.
Thanks for having me.
Okay, you got it.